Imagine we could use the boundless natural energy that the Earth provides. We could lower the cost of electricity to near 0 cents. On today's journey, we set sail towards a greener, more sustainable future. We point out the boundless possibilities and undeniable benefits of renewable energy. First of all, we have to ask the question, what is renewable energy? Renewable energy refers to sustainable sources of power that are naturally replenished, such as sunlight, wind, rain, tides, and geothermal heat. Unlike finite fossil fuels, renewable energy harnesses Earth's natural processes, offering a cleaner and more environmentally friendly alternative. These sources play a crucial role in mitigating climate change and reducing dependence on non-renewable resources, contributing to a more sustainable and resilient energy future.
Why do we need renewable energy? We need renewable energy for several reasons. Firstly, it helps combat climate change by reducing greenhouse gas emissions stemming from the burning of fossil fuels. Secondly, renewable energy sources are sustainable, ensuring a long-term energy supply unlike fossil fuels. Additionally, reliance on renewables enhances energy security by diversifying our sources, reducing geopolitical tensions related to fossil fuel extractions. Moreover, the renewable energy sector stimulates economic growth, creating jobs and forcing innovations. Overall, embracing renewable energy is essential for environmental preservation, energy security, and sustainable development. As you will see, there are many different ways to gain energy in an eco-friendly way. We will focus on the main and most efficient ways, such as solar energy, wind energy, hydro and water-based energy, and geothermal energy. Firstly, solar power. But what is solar power? Solar power is a conversion of sunlight into electricity. There are two ways to gain energy by solar. One is by concentrated solar power and one is by photovoltaics. We will also discuss the history of solar power and the limits. The first way to gain energy is by concentrated solar power, or short CSP. By CSP, sunlight is focused on a hotspot to generate heat. This heat is transmitted to water to drive a steam turbine. The second way is by photovoltaics, short PV. Simply said, photovoltaic cells convert light into an electric current using the photovoltaic effect. The photovoltaic effect is a phenomenon that describes the absorption of sunlight by a material and the therefore excitation of an electron to a higher energy state. This higher energy state is used to gain electric power. Now that we explained what solar power is, let's talk about its history. The first development of solar plants happened in the 1980s in the Gulf of Mexico. Its goal was to operate small signal systems for unmanned oil rigs. Since then, the producing of solar plants has doubled every 3 years. In 2050, solar power had generated 1% of the world's electricity. In 2022, it was already 4.5%, and half of the installed solar panels were rooftop. But solar power has its limits. One is areas farther away from the equator can't use solar energy to its full potential due to the shorter days and the change of seasons. That limits the time of active sunlight and the effectiveness due to the change of the angle of the sun. Another important point is weather. Covered sky by clouds block the sun and reduce the amount of energy created by solar power. That makes solar power a not reliable energy source in many parts of the world. Last but not least is the point how many space is needed for solar power. Even if half of the installed solar panels are rooftop, many power plants use a huge amount of space compared with the production of energy.
Wind energy is a renewable energy source that comes from the natural movement of the air. The wind energy is environmentally friendly and has low operating costs and reduce our dependence on fossil fuels. It can be produced during day and night. But wind energy has high construction costs depending on locations. The producing of wind energy. Wind turbines collect and convert the kinetic energy that the wind produces into electricity to power the electrical grid. The process of production. Wind energy is generated by wind turbines. When the wind hits the turbines' blades, it causes them to rotate. The rotor blades are connected to a generator that converts the mechanical rotational energy into electrical energy. The generator in the wind turbine produces alternating current, it's AC. The alternating current generated is usually not suitable for direct consumption because it has fluctuating voltage and frequency. The electrical energy generated is sent to a transformer on the wind farm. The transformer increases the voltage to minimize energy loss during long distance transportation. The energy is then fed into the power grid. The high voltage transmission. The wind energy is transmitted to the natural power grid via high voltage lines. The transformer stations are used to increase the voltage for transport and then reduce it again later. The electrical energy is transported to various locations, including cities and industrial areas. More transformer stations are used along the way to regulate the voltage. The energy goes to substations that are closer to the consumers. Here, the voltage and the distribution to different consumptions is further adjusted. The electrical energy now reaches users including private households, businesses and industries. The residential buildings electrical energy is provided by the local power grid. Consumers can use electrical devices now and the lighting by obtaining energy from the grid. The entire process makes it possible that the energy generated by wind from the wind farms to consumers to contributing to the electrical supply.
To continue, we dive into the realm of water-based energy production, exploring a rich capacity of renewable sources, each presenting its unique strengths and challenges. At the forefront is hydropower, a stalwart in the renewable energy landscape, celebrated for its reliability and consistent energy output. As we celebrate its benefits, we must also confront the environmental consequences it brings, altering river ecosystems and disrupting the delicate balance of fish habits. Moving on to dams and reservoirs, we witness an efficient system that stores water for controlled energy release, providing a dependable power supply. Yet, the grandeur of these structures wields a significant environmental impact, one that displaces ecosystems and reshapes the natural flow of water. The turbines, the heroes of water-based energy production, that play an untouchable role in converting the kinetic energy of moving water into a formidable source of mechanical power. As we applaud their effectiveness, let us not overlook the financial commitment required for their installation and maintenance. In the quest for a more environmentally conscious approach, we encounter run-of-river systems, minimizing the impact on ecosystems compared to their dam-centric counterparts. Yet the conscientious choice may come at the expense of lower energy output when compared to larger dam projects. Venturing into the oceanic realm, we unlock the potential of tidal energy, driven by the predictable and rhythmic ebb and flow of tides. However, this captivating energy source is geographically confined to coastal regions, blessed with robust tidal flows. Further out to sea, we explore the untamed power of wave energy, harnessing the perpetual motion of ocean waves. Yet the promise is it holds is juxtaposed against technological challenges and lingering concerns regarding its environmental impact. Our journey takes us to the tropical embrace of ocean thermal energy conservation, offering continuous electricity with minimal emissions. However, its application is restricted to regions where the ocean's temperature gradients align with its requirements. Here you can see some of the water-based power productions. They are implemented in the water. Amidst these technological marvels, we must not lose sight of our environmental responsibilities. Sustainable practices must guide us as we navigate the waters of energy production, ensuring minimal disruptions to our precious ecosystems. In summation, water-based energy sources hold the key to a sustainable and diversified global energy portfolio. Whether we look at the long-standing legacy of hydropower or the emerging frontiers of the wave energy, our responsibility is clear: to balance our energy needs with the preservation of our environment. Through responsible practices, ongoing research, and technological innovations, water-based energy becomes not just a source of power, but a vital force in shaping a cleaner, more sustainable future. For example, China built the biggest hydropower station, the Three Gorges Dam, which affects the near cities and provides energy for 5.4 million households each month. To go on, we'll explore the depths of the transformative energy source that lies beneath our feet. Geothermal energy. It's a journey into the Earth's core, unveiling the potential for sustainable power that resonates out of our planet. As a beginning, we have to point out what is geothermal energy. Like you may know, the hot springs all over the world that provides the heat of the inner core of our planet. Picture this: a boundless, renewable reservoir of heat beneath our Earth's surface. Geothermal energy harnesses this natural warmth, offering a continuous, sustainable source of power. It's the essence of our planet's vitality, waiting to be unlocked. But how does it work? Geothermal power plants, the gatekeepers of this remarkable resource, tap into reservoirs of steam or hot water beneath the Earth's surface. Imagine drilling into the Earth, extracting the essence of its heat. As steam or hot water rises, it powers turbines, generating electricity or providing direct heat for various applications. The biggest benefit is the capacity of this kind of energy. It's a renewable resource, sustainable and virtually limitless, providing a continuous stream of power without depletion. In an era where climate change is clearly visible, geothermal power plants emerge as champions of clean energy, emitting significantly fewer greenhouse gases compared to traditional fossil fuel-based plants. They contribute to the fight against climate change. Furthermore, the energy is almost everywhere reachable on our planet. Many corners of our world are blessed with the geothermal reservoirs. Harnessing this power locally reduces the need of expensive energy transportation, aligning seamlessly the sustainability goals. But there are also many downsides, as the new technology is not approved a lot, and there are many problems that can't be calculated, such as the risk of earthquakes or volcanic activities, which are affected by drilling deep into inner cores of the Earth. However, you think it can't get worse? The work that's to be done is high, and due to this, it's very costly. The process of drilling deep into the Earth incurs highly initial costs, challenging the widespread adoption of this promising energy source. In conclusion, geothermal energy stands as a beacon in our pursuit of sustainable power sources. Its renewable nature, low emissions, and baseload power potential paint a promising picture for a cleaner, greener future. Yet, we must navigate with care, addressing challenges like location dependence, upfront costs, and land use. As we journey towards a more sustainable and diverse energy landscape, let us embrace geothermal energy as a powerful ally in our quest for a brighter and cleaner tomorrow. As we come to visions of the future, the impact of the renewable energy on the future is profound, shaping a more sustainable and resilient world. As we embrace these clean energy sources, we pave the way for a future with reduced carbon emissions, mitigated climate change effects, and enhanced environmental absorption. The conscious advancement of technology in the renewable energy segment further accelerates this transformative journey. In the future, we can anticipate breakthroughs in solar energy with more efficient and affordable photovoltaic cells, as well as innovations in energy storage technologies, addressing the intermittent nature of renewables. Wind energy will witness the evolution of more sophisticated turbine designs, optimized for efficiency and environmental integration. Additionally, emerging technologies like wave and tidal energy, along with enhanced geothermal solutions, hold promise for diversifying the renewable energy portfolio. But you can't underestimate the new evolution of the reactor technology. There are promising startups that search for solutions to overcome the radioactive waste. One interesting idea is a dual fluid reactor invented from the TU Berlin, where they promise to convert radiated waste into energy due to a new model of reactors.